Hey there, and welcome back to the Deep Dive. Today we're digging into something really fundamental about history, why certain parts of the world developed so differently. We're looking at this idea, famously explored by Jared Diamond in Guns, Germs, and Steel, the idea that really basic things like farming and, crucially, which animals got domesticated, set the stage for huge imbalances later on. Power, tech, even disease immunity. So the big question is, why these animals and not others? And how did that choice, or maybe lack of choice, lead to these massive, sometimes devastating consequences, especially with diseases?
Exactly. And to get at that, we're actually going to use a concept from, believe it or not, literature, Tolstoy's Anna Karenina principle.
The novel, how does that fit in?
Well, it's surprisingly useful here. It gives us a really clear way to understand why only a handful of animals ever became domesticated, while most stayed wild. So our mission really is to break down the exact conditions an animal had to meet. All of them. And then, trace how that split affected human health and power across the globe. It's quite a story.
Okay, I'm intrigued. Anna Karenina and cows. How does that famous opening line, "Happy families are all alike. Every unhappy family is unhappy in its own way," apply to, well, animal domestication?
Right, that's the line. And it applies because, just like a successful marriage needs a whole bunch of things to work, trust, communication, shared goals, all that. Successful domestication also needed a whole checklist of traits to be present in the animal species. If even one of those essential traits was missing, it just wouldn't work. Domestication failed. It didn't matter if the animal met 5 out of 6 criteria, say. Failure in one meant failure overall.
Ah, okay. So it's not like picking the best animal. It's about finding the incredibly rare species that happen to tick all the boxes.
Precisely. It's an all-or-nothing proposition. Very few species actually made the cut.
So it's really strict then. What are these non-negotiable conditions? Let's break them down.
Okay, condition number 1, diet. Basically, what does it eat, and is it efficient for us to feed it? There's a basic biological rule of thumb. Roughly, only about 10% of the biomass an animal eats gets converted into its own body weight.
10%?
Yeah, so think about a cow, maybe 1,000 pounds. To get that big, it needs to eat something like 10,000 pounds of grass or feed over its life. Now imagine trying to domesticate a large carnivore, like a lion or tiger of the same size.
Uh-oh.
Right. It would need 10,000 pounds of meat. And the animals providing that meat, they also needed 10 times their weight in food.
Okay, that pyramid gets ridiculous fast.
Exactly. It's incredibly inefficient, which is why, almost without exception, the major domesticated mammals are herbivores or maybe omnivores. Feeding large carnivores at scale is just impractical.
Makes perfect sense. So rule 1, got to be cheap to feed, basically. What's next?
Condition 2, growth rate. They need to grow reasonably fast.
To be worth the effort.
Right. You got it. If an animal takes forever to reach a useful size, why bother raising it? Think about, say, gorillas or elephants. They're big herbivores, lots of meat there.
Right.
But they take maybe 15 years or so to mature. For an early society, it's just much more practical to hunt the occasional adult elephant than to spend 15 years raising one. Slow growth is a deal breaker.
Okay, so fast growth. What's condition number 3?
Number 3 is about problems with captive breeding. Can we actually get them to reproduce reliably when we want them to? Some animals just don't do well breeding under human control. Maybe they have really elaborate courtship rituals that get disrupted.
Like they need privacy or a special dance or something.
Kind of, yeah. Some are very shy maters. Others need, a specific multi-day chase or ritual, things that are hard to replicate or manage in a confined farm setting. Yeah. If you can't reliably breed them, you can't sustain a domesticated population.
Right, you need offspring. Okay, what's number 4? This list is getting tough.
Number 4 is pretty straightforward. Nasty temperament.
The obviously dangerous ones.
Exactly. Animals that are inherently too aggressive, unpredictable, or just plain dangerous to be around humans regularly. Think grizzly bears, obviously. Or African buffalo, which are notoriously aggressive. Hippos kill more people in Africa than almost any other large animal. They're out.
Okay, so no surprise there. But you mentioned earlier, like zebras. They look like horses, but they didn't make the cut because of temperament.
That's a perfect example. Zebras look the part, they're herbivores, live in herds. But they have a really nasty disposition. They tend to panic, they bite hard, they have a powerful kick, and they've proven incredibly resistant to being truly tamed or ridden reliably, despite many attempts.
Huh. So nasty isn't just about being a predator, it's about being manageable day to day.
Precisely. Consistency and safety are key, which leads nicely into number 5, tendency to panic. This is about how they react to being enclosed or feeling threatened. Some animals are just too high-strung.
Like they freak out easily.
Yeah, pathologically so. Gazelles are often cited here. You put them in an enclosure, and their instinct is just blind flight. They can literally panic so badly they'll smash into fences at full speed, injuring or even killing themselves. You just can't keep animals like that contained effectively or safely.
Wow. Okay, yeah, that wouldn't work at all. Self-destructing livestock is not a good plan.
Yeah.
So, one condition left. What's the final hurdle?
The sixth and final condition is social structure. This one's a bit more nuanced. Ideally, you want animals that already live in herds or groups. And crucially, those herds should have a well-defined dominance hierarchy, like everyone knows who's boss and where they fit in.
Okay, why is that important?
Because humans can essentially hijack that system. We can insert ourselves, or our dogs, as the leader figure. The animals are already programmed to follow a leader and stay with the group. Think sheep, cattle, horses. They have that herd instinct and hierarchy that we can exploit for herding and control. Also important is that their territories aren't strictly defended against others in the herd, they overlap. Highly territorial animals are really hard to manage in groups.
So solitary territorial animals are mostly out.
Mostly, yes. The big exceptions people point to are cats and ferrets. And they're interesting because their domestication seems to have been different, more like they adopted us for pest control benefits, kind of a self-domestication almost, rather than us imposing leadership on a herd structure.
That's fascinating. 6 really specific conditions. Diet, growth, breeding, temperament, panic, social structure. You miss one, and no domestication.
That's the core idea of the principle applied here. Very few animals picked all 6 boxes.
And this relative lack of suitable animals in some parts of the world compared to, say, Eurasia, leads us to the really big unforeseen consequence, right? The germs part.
Exactly. This is where it gets, well, quite grim, historically speaking. Because living in close quarters with these newly domesticated animals, cows, sheep, pigs, chickens, wasn't just about food and labor, it was also about germs.
Our diseases came from them.
Many of the major ones, yes. Measles, tuberculosis, smallpox, influenza. Many of these devastating infectious diseases seem to have originated as animal diseases that eventually jumped species into human populations. Think about it. Dense agricultural societies, people living cheek by jowl with large numbers of animals breathing the same air, handling manure, drinking contaminated water. It created the perfect conditions for pathogens to cross over.
Okay, so Eurasia had lots of these animals, lived with them for millennia.
Right. And over thousands of years, those populations were repeatedly exposed to these animal-derived pathogens. Epidemics swept through, people died, but over time, those societies built up some degree of genetic resistance and immunity. Horrible process, but it led to immunological defenses.
But in places like the Americas or sub-Saharan Africa.
Much fewer domestical animals to begin with. Remember the 6 conditions. The Americas, for instance, only really had the llama alpaca. Africa had some candidates, but factors like disease, trypanosomiasis affecting cattle, and maybe the zebra's temperament limited things. So fewer animals meant fewer animal-derived diseases jumping to humans, which meant the populations there didn't build up the same kind of immunological library over the centuries.
And then Europeans arrived.
And they brought their germs with them. Smallpox, measles, flu, diseases that were often childhood illnesses in Europe, but were completely novel and catastrophic to populations in the Americas.
The impact was unbelievable, wasn't it? Far worse than the guns.
Absolutely devastating. Estimates vary, but something like 90–95% of the indigenous population in the Americas may have died from these imported diseases. It was arguably the single biggest factor in the European conquest, a truly ruthless historical reality driven ultimately by which animals happened to be available and suitable for domestication thousands of years earlier.
It really reframes history, doesn't it? Not just about human choices, but about these deep biological constraints and their explosive consequences. That chance lottery of animal availability setting the stage for global power shifts.
It really does. And that's the power of looking through that Anna Karenina principle lens. It helps clarify how meeting or failing to meet a specific set of seemingly small biological requirements could lead to such vastly different historical trajectories. Success required everything to be right. Failure could happen in many ways. So maybe something for you to think about is just that. How these factors that seem almost mundane, what an animal eats, how fast it grows, its social habits, even how easily it panics could cascade through millennia, how they could end up shaping not just our diets, but our disease history, our population densities, and ultimately the fates of entire civilizations. It really makes you wonder what other subtle underlying factors are shaping our world right now in ways we don't fully appreciate.